Write the eccentricity of the hyperbola 9x square minus 16y square is equal to 144, which can be written as 9x square upon 144 minus 16y square upon 144 is equal to 144 upon 144 by dividing 144 on both the sides. So 9 16 times and 16 9 times 144. So we can write it as x square upon 16 minus y square upon 9, which is equal to 1, which is the standard form. X square by a square minus y square by b square is equal to 1, standard form of hyperbola, where a is greater than b. So here a square is equal to 16 and b square is equal to 9, and eccentricity is given by e is equal to under root of 1 plus b square by a square when a is greater than b. So we can write eccentricity e is equal to under root of 1 plus b square, that is 9 upon a square is 16, so which is equal to 16 plus 9 upon 16. So square root of 16 plus 9, that is 25 upon 16. Root of 25 is 5 and root of 16 is 4. Since eccentricity is positive, it's greater than 1, so we consider positive value of root of 25 by 16, so which is 5 by 4. So eccentricity of the hyperbola 9x square minus 16y square is equal to 144 is 5 by 4. Write the eccentricity of the hyperbola whose latus rectum is half of its transverse axis. Let us consider the standard form of hyperbola. X square by a square minus y square by b square is equal to 1. So where a is greater than b, and here the transverse axis is x axis. So length of transverse axis is which is 2 times a, and latus rectum the length of latus rectum is equal to 2 times b square upon a, and eccentricity E is equal to 1 plus b square by a square, the whole under root. Okay, so it is given length of latus rectum is, say this is L, is half of its transverse axis, that is 1 by 2 into 2a, so that is a. So length is written by length of latus rectum is 2b square upon a is equal to a, upon simplifying 2b square is equal to a square. Make this an equation 1, and let us substitute in eccentricity. This is a, let us take this is 2. So from 1 and 2, eccentricity E is equal to under root of 1 plus b square upon a square is nothing but 2b square. So you can cancel b square and b square. This is root of 1 plus 1 by 2. So which is under root of 2 plus 1, 3 by 2. So root 3 by 2 is the answer for the question. Write the coordinates of the foci of the hyperbola 9x square minus 16y square is equal to 144. So this equation can also be written by dividing 144 both the sides. So we have x square upon 9 16 times and y square upon 16 9 times, which is equal to 1, which is in the form of x square by a square minus y square by b square is equal to 1. Here a square is greater than b square, that is a is greater than b, we can consider, and the foci of this hyperbola can be considered plus or minus ae comma 0, and eccentricity e is equal to under root of 1 plus b square by a square. So here a is equal to, or a square is equal to 16, b square is equal to 9, so we can consider e is equal to 4, and eccentricity e is equal to under root of 1 plus b square, that is 9 upon a square is 16, so which is root over 16 plus 9, 25 upon 16. So eccentricity of the given hyperbola is 5 upon 4, so we consider the positive value since eccentricity is greater than 1. And then foci, the coordinates of foci. Coordinates of foci can be considered plus or minus ae. So a is nothing but 4 into 5 by 4 comma 0, that is we can write plus or minus 5 comma 0. So plus 5 comma 0 and minus 5 comma 0 are the coordinates of foci of the given hyperbola. Write the equation of the hyperbola of eccentricity root 2 if it is known that the distance between the foci is 16. So let us consider the standard form of hyperbola. X square upon a square minus y square upon b square is equal to 1. So where a is greater than b and the transverse axis is on x axis. So and eccentricity, whose eccentricity e is equal to root 2 is given, and distance between the foci. So here the foci is considered plus or minus ae comma 0. So distance between the foci is will be considered 2ae, the length. So distance between the foci is given 16 units, that is 2a is equal to 16, and also e is equal to root 2. So let us substitute from 1 and 2. From 1 and 2, so we can write 2 into a into root 2 is equal to 16, or a is equal to 16 upon 2 root 2. So here 2 8 times 8 upon root 2. So a square is equal to 8 by root 2 whole square, that is 64 upon 2, which is 32. So the value of a square is 32, and we know that eccentricity is e is equal to, or eccentricity e is equal to under root of 1 plus b square by a square, or we can write e square is equal to 1 plus b square by a square. Since the e is equal to root 2, so root 2 whole square is equal to 1 plus b square upon a square is 32. So upon simplifying, we will get root 2 whole square is 2 and minus 1 is equal to b square by 32, or we can write b square is equal to 2 minus 1, 1 into 32 is 32. So hence the equation of hyperbola, is x square upon a square is 32, minus y square upon b square is 32, which is equal to 1. So we can write x square minus y square is equal to 32 by taking LCM as 32. This is the required equation. If the foci of the ellipse x square upon 16 plus y square upon b square is equal to 1, and the hyperbola x square upon 144 minus y square upon 81 is equal to 1 upon 25 coincide, then write the value of b square. So let's consider the standard form of an ellipse. X square by a square plus y square by b square is equal to 1. So we have a square is equal to 16, so which implies a is equal to 4, and then eccentricity, let us consider to be even, is equal to under root of 1 minus b square by a square, that is under root of 1 minus b square upon a square value is 16. So we can write under root of 16 minus b square upon 16, and the foci of an ellipse can be considered plus or minus ae comma 0, so which can be taken plus or minus a value is 4 into e value is, so that is eccentricity e1 value, let us consider root of 16 minus b square upon square root of 16 is 4 comma 0, that is we can cancel this 4 and 4, so we can take plus or minus root of 16 minus b square comma 0. And coming to the hyperbola, so this equation can also be written as x square by, or we can write 25 times x square by 144 minus y square by 81 is equal to 1, or we can write x square upon 144 by 25 minus y square upon 81 by 25, which is equal to 1. So when comparing with the standard form of hyperbola, x square upon a square minus y square upon b square is equal to 1. So we have a square is equal to 144 upon 25, that is a value we can consider 12 upon 5, since it is 12 upon 5 whole square. And then eccentricity, let us consider eccentricity e2 is equal to under root of 1 plus b square by a square, which is equal to under root of 1 plus b square value is 81 upon 25 divided by a square value is 12 upon 5 whole square, that is 144 upon 25. So 25 and 25 gets cancelled. So we have under root of 144 plus 1, that is 225 divided by 144, which is 15 upon 12. So eccentricity E2 is equal to 15 upon 12, or we can cancel this 3 5 times and 3 4s are 3 5 times and 3 4s are, this is 5 by 4. And then foci of an ellipse will be taken plus or minus a e2 comma 0, where a is equal to 12 upon 5, so plus or minus 12 by 5 into eccentricity e2 is 5 by 4 comma 0, so that is plus or minus 5 get cancelled and 4 3 times, so getting 3 comma 0. Since eccentricity of foci of ellipse and hyperbola are coincide each other, foci of given ellipse and hyperbola coincides, which implies that plus or minus 16 minus under root of 16 minus b square comma 0 is equal to plus or minus 3 comma 0, that is root over 16 minus b square is equal to 3. So on squaring on both sides, 16 minus b square is equal to 3 square, that is 9, or b square is equal to 16 minus 9, that is the value of b square is 7. So the question is, so we need to find the value of b square, so the b square value is 7. Okay. Write the length of the lattice rectum of the hyperbola 16x square minus 9y square is equal to 144, which can be written as 16x square upon 144 minus 9y square upon 144 is equal to 144 upon 144, so which is x square upon 16 9 times and 9 16 times y square upon 16 is equal to 1, so which is the standard form of the hyperbola x square upon a square minus y square upon b square is equal to 1, whose lattice rectum length is length of lattice rectum is equal to 2 times b square upon a, which is equal to 2 into, so when comparing with the standard form, so here b square is equal to 16 and a square is equal to 9, that is a is equal to 3 we can consider, so 16 upon 3, so which is 16 to the 32 upon 3. So the length of lattice rectum for the given hyperbola is 32 upon 3 units. If the lattice rectum through one focus of a hyperbola subtends a right angle at the farther vertex, then write the eccentricity of the hyperbola. Let us consider the standard form of hyperbola: x square upon a square minus y square upon b square is equal to 1. Let us take the diagram. Let's consider the rough diagram. Focus will be considered. Let's consider the focus is a comma 0. A line which is drawn perpendicular to the axis passing through the focus is called a lattice rectum. Let us consider P and Q are the ends of lattice rectum. Endpoints of lattice rectum are given by P AE comma B square upon A and Q AE comma minus B square upon A, and it subtends a right angle at the farther vertex. The farther vertex will be A dash. So vertex A dash is taken minus A comma 0. It subtends a right angle. So P A dash is perpendicular to Q A dash. So P A dash is perpendicular to Q A dash. So which implies that slope of P A dash into slope of Q A dash is equal to minus 1. So by taking the 2-point form, y2 minus y1 by x2 minus x1 slope formula, so we can write slope of P A dash is b square upon a minus 0 by ae minus of minus a, that is ae plus a, into slope of q a dash can be taken minus b square upon a divided by ae minus of minus a, that is ae plus a is equal to negative 1. Upon simplifying, we can write b power 4 upon a square is equal to 1, that is a times of or a square times of e plus 1 whole square, or we can write b power 4 by a power 4 is equal to e plus 1 whole square, or e plus 1 can be considered b power 4 by a power 4 whole root is nothing but b square by a square, so that e is equal to b square by a square minus 1. On squaring on both sides, e square is equal to b square by a square minus 1 whole square. Upon simplifying, you will get b power 4 by a power 4 plus 1 minus 2 times of b square by a square. Let us use the eccentricity of hyperbola. We know that eccentricity of hyperbola e square is equal to 1 plus b square by a square. So let us substitute e square is equal to 1 plus b square by a square on the left side, and the right side we have b square by a square whole square minus 2 times of b square by a square plus 1. So plus 1 on both the sides get cancelled. So we have b square upon a square plus 2 times of b square upon a square is equal to b square upon a square whole square, that is b square upon a square into b square upon a square. So that is 3 times b square upon a square is equal to b square upon a square into b square upon a square. So we can cancel one b square upon a square term both the sides, so which implies that b square upon a square value is 1. And then now let us substitute in the eccentricity. So we have eccentricity e square is equal to 1 plus b square upon a square, so which implies e square is equal to 1 plus 1, that is e square is equal to, so we have e square is equal to 1 plus b square upon a square, sorry, this is b square upon a square is equal to 3, so 1 plus 3 we have, so which is 4, so e is equal to square root of 4, so we'll consider the positive value since eccentricity for hyperbola is greater than 1. Therefore, eccentricity of the given condition based hyperbola is 2. Write the distance between the directrices of the hyperbola. X is equal to 8 secant theta and y is equal to 8 tan theta. So parametric equations of a hyperbola is given. So we can write x upon 8 is equal to secant theta and y upon 8 is equal to tan theta, squaring on both sides. X square upon 64 is equal to secant square theta and y square upon 64 is equal to tan square theta. Since we know that secant square theta minus tan square theta is 1, so from 1 and 2 we can write x square upon 64 minus y square upon 64 is equal to secant square theta minus tan square theta, which is equal to 1. So we can write x square minus y square is equal to 64, or we can write x square by 8 square plus y square by 8 square is equal to 1. So here a is equal to b is equal to 8. The directrices of the hyperbola in standard form. Directrices equation is x is equal to plus or minus a by e. Therefore, distance between two directrices is equal to 2 times a upon e. So let us find the eccentricity. Eccentricity e is equal to under root of 1 plus b square upon a square, which is equal to 1 plus b square value is 64 upon a square value is 64. So that is 1 plus 1, which is equal to root 2. Therefore, distance is the required distance, that is the distance between the two directrices. D is equal to 2 into a value is 8 upon e value is root 2. Let us multiply and divide with root 2. So we have 2 into 8 into root 2 upon 2. So which is 8 root 2. So 8 root 2 units is the distance between the two directrices of the given hyperbolic equation. Okay. Write the equation of the hyperbola whose vertices are plus or minus 3, 0 and foci plus or minus 5, 0. We know that for standard hyperbola, x square upon a square minus y square upon b square is equal to 1. Its vertices are plus or minus a, 0 and foci plus or minus a, 0. So given vertices plus or minus 3, 0 and foci is plus or minus 5 comma 0. So from here we can consider A is equal to 3 and A is equal to 5. So substitute A is equal to 3 here. So 3 times E is equal to 5. So the eccentricity of hyperbola E is equal to 5 by 3. Then we have eccentricity E square is equal to E square is equal to 1 plus B square by A square. So 5 by 3 whole square is equal to 1 plus B square upon 3 square. We can write 25 by 9 minus 1 is equal to B square by 9. We can write 25 minus 9, that is 16 upon 9 is equal to B square upon 9, which implies that B square is equal to 16. Hence, the required equation of hyperbola is x square upon a square. Since a is equal to 3, so a square is equal to 3 square 9 minus y square upon b square value is 16, which is equal to 1, or we can simplify and we can write 16x square minus 9y square upon 144 is equal to 1. We can give the answer as 16x square minus 9y square is equal to 144 is the answer. If E1 and E2 are respectively the eccentricities of the ellipse, x square upon 18 plus y square upon 4 is equal to 1, and the hyperbola is given x square upon 9 minus y square upon 4 is equal to 1, then the value of 2 times E1 square plus E2 square is. So comparing the given ellipse equation with x square upon a square plus y square upon b square is equal to 1, so whose eccentricity, let us consider E1 is equal to under root of 1 minus b square by a square. So that is E1 square is equal to 1 minus b square by a square. So here a square is equal to 18 and b square is equal to 4. Therefore, E1 square is equal to 1 minus 4 upon 18. So 18 minus 4, it's a 14 upon 18. So 2 7 times and 2 9 times. So E1 square is equal to 7 by 9. And similarly, for the hyperbola, when comparing with an equation, standard form of hyperbola, x square upon a square minus y square upon b square is equal to 1. So we have eccentricity, say E2 is equal to under root of 1 plus b square by a square, or we can simplify and write E2 square is equal to 1 plus b square by a square. So when comparing with this form, so we have a square is equal to 9 and b square is equal to 4. So which implies that E2 square is equal to 1 plus 4 upon b square is 4 upon a square is 9. So that is 9 plus 4, 13 upon 9. So E2 is equal to, or E2 square is equal to 13 upon 9 we can write, and hence since we required that 2 times E1 square plus E2 square, so 2 times E1 square plus E2 square is equal to 2 into 13 upon 9 plus E2 square is 13 upon, 2 into 7 upon 9. E1 square value is 7 upon 9 plus E2 square is 13 upon 9, which is equal to 14 plus 13 upon 9, that is 27 upon 9. So 9 3 times, So therefore we can say 2 times e1 square plus e2 square value is 3. Okay.